right now. We're on our opening keynote on scalable, feeless, and flexible smart contracts for enterprise application and real-world use cases. And we're joined by Sergei Popov, the founder of IOTA Foundation. Well, Sergei has a PhD in math, 1997, Moscow State University, and is one of the IOTA co-founders, together with Sergei Evangeliko, David, and Dominique as well. He's somebody who's in charge of the theoretic and the conceptual side of IOTA. And thank you so much, Sergei, for joining us and giving us your valuable time at the World Blockchain Summit. I may request you now to join us on our stage and screen right now. Thank you.
Okay, thank you. Thank you for inviting me. So
could we have your video on, please? I'm not able to see you.
Oh, wait, let me do it again. Oh, that's strange.
Yes, perfect. Now fine.
Yeah.
Thank you.
Now fine. Okay, so let me share my screen now. And I have to say that there was some accident, probably because I'm not going to talk a lot about smart contracts in IOTA. I will talk more about basic principles and approach to consensus.
Perfect. Thank you so much. Over to you.
But still, I can say that we have quite an interesting concept about smart contracts and how are they handled in IOTA. But I'm afraid that's not for today. But stay tuned. It's great, and it will be available soon. Okay. So for now, I will speak about this basic principles and approach to consensus. So IOTA Tangle was started, well, almost 6 years ago. And the initial idea was to make a cryptocurrency for Internet of Things. And if you want a cryptocurrency for Internet of Things, where you can imagine that there will be a lot of really small value transactions, like fractions of cents or something, or even no value transactions, which just send some data around, it would be really desirable to get rid of transaction fees. Because, well, it's fine to pay a $5 fee when you buy a helicopter, but it's not fine to pay it when you buy a cup of coffee or something. So you need to design a system with no transaction fees. Then, if you don't want transaction fees, you actually don't want to create this dichotomy between miners and simple users. Miners are someone that have some resource that simple users don't have, and they would want to somehow capitalize on that. They would want to make profit on the resource, so like mining ASICs or stake that they invested to. So basically, if you want no fees, you need to have a homogeneous systems on the users. So you need a collaborative systems based on this principle. Help the others, and the others will help you. Now, it sounds great, but all systems of this sort have problem of so-called free riders. Think about BitTorrent, for example. in principle, BitTorrent is a great idea that people would just exchange the files that they have somehow, and in practice it does not work really well from the beginning because of free riders. People are just go there, get what they want, and then turn the BitTorrent client off and don't collaborate with the others anymore. So that's why BitTorrent and such, they had to introduce some complicated rating systems and so on. So anyway, we need to amend the main principle to this: help the others and the others will help you. However, if you don't help the others, then the others also will not help you. That is, we need somehow incentives to participate. And let me just comment that we regard as the very possibility of you participating in the system, of you being part of the economy, is already an incentive. So we think that it's not kind of strictly necessary to have a separate rewards, for example, for you to run a IOTA network node, because, well, you naturally want to be part of the economy where things happen. Yeah. So now, if you have no miners, you can't have really blocks in the sense of containers of several transactions, individual transactions, because who will form these blocks? How there should be the system should be organized like the users put directly their transactions into the ledger, and then the principle of no blocks plus the principle of help the others naturally leads us to this DAG ledger, which is directed acyclic graph, which is basically this structure here. So each small box on this picture is a transaction, and it has two arrows like this, here and here. And this arrows means that when you issue a transaction, you have to verify two other transactions. So this is the help the others part. When I issue my transaction, I verify something that was put into the ledger before me, and this way I help the system, because then others will come and they would verify my transaction and vouch for it. So in principle, this is how it goes. So then, of course, we had to kind of design the rules of the system. Well, I will speak about this a bit later. So in principle, we have only one rule: approve two transactions. Well, in fact, these two here, I think we will increase it actually to 8 in some time, but it's just a parameter. And this gives a lot of freedom to the system, because you can construct some mini blockchains here if you need. You're not forced to anything, and when you have freedom, it makes the system really flexible. So the designer's role is to propose a good set of rules for example, where would you attach your own transaction in such a way that the others would be willing to help you. So these rules should be that if you behave well, then others collaborate with you, and if you don't behave well, for instance, if I choose a couple of really old transactions just not to verify this whole stuff here, then I'm free to attach my transaction here, but others will likely not collaborate with me, or at least will not collaborate with me really quickly. I will maybe have to wait more for my transaction to be verified. Yeah, so currently we have this coordinator device in the network, which basically acts as the finality device. So you are still free to include whatever, but your value transaction is verified when this coordinator is confirming it directly or indirectly, in the sense of directed path which leads there. And the core decide is the project which is in an advanced phase right by now already, which basically killing of the coordinator, making the consensus absolutely decentralized in IOTA. And the general ideas behind it are this: we are looking for a probabilistic consensus. This is something that we mathematicians call exponential bits polynomial. So basically, when the probability of an individual, the probability that something bad happens with an individual transaction is exponentially small in some parameter. You can think of this n as the size of the system. And well, the size of the system, the time which goes all, let's say, polynomial and n, and then it happens that basically bad things will not happen in practice. So it's important to keep in mind that even if probability of something is theoretically positive, it does not yet mean that it will ever happen in practice. Just think of an example. Think of your Bitcoin wallet. If I just write some bits randomly, now I have strictly positive probability to guess your private key. Still, this does not mean that your Bitcoins are in danger, because this probability is really, really small. So I can take all time in the universe and I will not guess it. So another idea is that we can use an approximate consensus. For example, on time. You know, time is something on which people have an approximate consensus already, because more or less everybody, at least overwhelming majority of people, would agree which time is now up to one couple of minutes. Modulo time zones, of course. And we can use this sort of approximate consensus to achieve the total consensus on transaction validity with very high probability. And well, it's there is something which I call consensus as an attracting state. And well, this is a bit complicated mathematical subject which I cannot explain in a few minutes right now, but I gave a couple of lectures on this IOTA Evangelist Network talks. You can find them easily on YouTube, and I would recommend to see it. Hopefully it's interesting. So some implementation details of the core decide. So the nodes can resolve conflicts proactively. So if there are two transactions that contradict each other, the network have to choose one of them, or maybe invalidate both. That's also an option. So there is a paper of myself and Bill Buchanan, which we call FPC, or Fast Probabilistic Consensus within Byzantine Infrastructures. Well, there is something called MANA, which we use for civil protection. Well, this reminds of proof of stake systems, but I think it's a bit more advanced. Well, there are some networking stuff like auto peering and so on to protect against eclipse attacks when a honest node is surrounded by attackers. Yeah, and then there is this, and you can look at this site, which is maybe a bit outdated by now, but still nice. We have a research forum here. We have this Tangle Math channel at the community Discord, where all these things can be discussed. And this is this test implementation of the core site, which is advancing well, and you can test it already here. Just want to add a couple of words about fast probabilistic consensus. It is essentially something which is called majority dynamics, or threshold water models in mathematics. It is, these are well-known mathematical models which were extensively studied from 70s. So they have more or less the same age as myself. And basically it's this: there is a graph, each side of which has an opinion 0, 1. At random moment, each side would consult a few neighbors, not a lot of them, and would adopt new opinion using a majority rules. Like if everybody, or at least some majority of my neighbors have opinion 0, I say, okay, maybe I should think 0. But if everybody, or at least majority of, in some sense, of my neighbors have opinion 1, I say, okay, I should think 1. And yeah, there are a lot of this sort of models in mathematics, and they have only 2 what we call extremal invariant measures, which is again a little bit complicated notion, but it basically says that this sort of dynamics will come to consensus. Everybody will agree on 0, everybody will agree on 1 in the end. So we can somehow visualize this dynamics as a random walk on a potential. So again, it's a bit an advanced subject, but you can do it. And the reason why it is difficult to use the pure majority dynamics is that this sort of majority dynamics is really not Byzantine resistant. So you cannot use a pure just simple sort of majority dynamics or simple sort of water model for achieving consensus with adversaries, because they basically may delay it a lot. They may kind of so we think about consensus like this this object is fluctuating on a mountain, but eventually it will fall either here to, let's say, all zero state, or there to all one state. But Byzantine actors can do this. They can create a small hole. Well, not really small, a hole in the on the top of this mountain, which will delay this ball here in this hole for a lot of time. So actually, from some statistical physics and mathematics, you know that the time you spend here is exponential in this height, which means a lot. And yeah, they can do something that the fast probabilistic consensus introduces an idea of defeating this meta-stability effect, which is bad, with turn-based common random thresholds. So these random thresholds, they act in this way. So just in one round, you have a positive chance of either jumping to this slope and then going down, or jumping to that slope and then going down. So this is a metastability breaking mechanism which permits to use this sort of majority dynamics for practical consensus. Then I guess I'm done. Yeah, it was 20 minutes. Thank you for your attention.
Thank you so much, Sergei, for joining us and giving us your valuable time today at the World Blockchain Summit. It's always great to get more insights, and especially from the experts, because it only adds more value to all the delegates who are attending today, because they say that knowledge is what one always urges to get. So thank you once again for joining us today.
Thank you very much.
Thank you. God bless.
Goodbye.
Take care.